Part B. Our instructions are simply to solve, which means we need to find the values of x, y, and z, which will make all three of these equations true. And you notice something a lot different here. Let me read them. X plus z equals 0. 4y plus 3z equals negative 2. 2x minus 5y equals 3. And you notice, okay, yeah, there are three equations. There are three variables, x, y, z. But each equation only has two of them. And we've got every different combination, right? X and Z, Y and Z, X and Y. So it turns out our work to solve this is going to be a lot simpler if not all three equations contain all three variables, like in part A. If all three equations have all three variables, then we had that same goal. We have to go about it the same way we did that I showed you guys, right? To pick two different pairs and eliminate the same variable twice. But if some or all of your equations are missing some of the variables, it might be a lot simpler. Truth is, there's really no one way. However you get to this goal, get there. Of course, some methods are faster than others, but as long as you get there with all true statements, getting two equations with two variables, it doesn't matter how you do it. So we're going to do this one with a much faster approach. Now there are many variations here because we could start with any one equation. I'm going to start with that first equation, x plus z equals 0. Okay. And just because it's the simplest, really. And I'm going to say, okay, if x plus z equals 0, doesn't x equal negative z? Well, sure, if I just subtract the z. I mean, I can see that. Well, how is this helpful if I isolate x here in that equation? So I can now take the fact that x equals negative z, and I can plug negative z into the x in that third equation, the other equation that has x. So I use this equation that has x, and then I plug that into the other equation with x. And I think I even plug x into equation 3. Yeah. What's that going to do for me? Well, just kind of follow along and it'll be clear. 2 times negative z minus 5y equals 3. Okay, let me pull this up for what I'm going to show you. So I'm plugging z into that third equation. So that means negative 2z minus 5y equals 3. Now, just the way this is written, we haven't come to any revelations yet. But I do notice that the z is first and the y is second. And I'd prefer it to be the other way around. It's good to keep them in order the way the elimination works. So I'm going to rewrite that as negative 5y minus 2z, just switch the order of those, equals 3. It turns out this is the first of my two equations with two variables. The other one is that second equation. It has y and z as well. So very quickly, I've got my first equation with y and z, and then I can already see there's another one with y and z. 4y plus 3z equals negative. I've got two equations with my two variables. And what's important is, of course, the two variables are the same two variables in each one, both with y, both with z. And I've reached that goal, and it was a lot faster this time than the way it had to play out in part A. The part A, that was the fastest way we were going to be able to get it. Again, what did I do? Let's just kind of review this, because this is the key step in the problem, is obtaining that goal before we can move on. When some of your equations don't have all three variables, isolate one of the variables in one of them. And here it was very easy to isolate that x. And then plug what it equals back into, another equation that had x in it. And then you're just hoping something just falls into place and you don't really see where it's going, in all details. That's okay. Just kind of follow your nose, put that in, boom. Hey, I've got an equation with y and z. Hey, there's another equation with y and z. And I'm done, at least with my first goal. Okay, hopefully that makes sense. Now it's our duty to solve this, and I'm going to use elimination. Okay. Nothing immediate, but I do notice negative 2z, positive 3z. That's negative, that's positive. Same true for y, I suppose, but these numbers are smaller. Here's what I'm going to do. I'm going to multiply equation 1 by 3 and multiply equation 2 by 2. So that will give me negative 6z and positive 6z. Of course, I got to multiply all the things out, but I'll be able to eliminate z. All right, when that 3 goes to all three parts of the first equation, I've got negative 15y minus 6z equals 9. Multiply equation 2 by 2. So that will give me 8y plus 6z equals negative 4. And perfect. When I add, the z's will be gone. What else do I get? Negative 15 plus 8, negative 7y. Then the z's are gone. 9 plus negative 4 is 5. Okay, negative 7y equals 5. To get y, well, I'm going to divide by negative 7. And, well, I've got a fraction. It happens. We do have answers to systems that are fractions. That's the way it goes. Okay, we're going to proceed. This is why we have calculators. Don't be intimidated. So what do we do from here? Well, really the hard part is getting that first variable value. We're now going to take this and we're going to back substitute it into either of these equations for y. We'll be able to figure out what z is. I forget which one I picked. Oh, I picked the first of those two. It was negative 5y minus 2z equals 3. I could have picked the second one. It doesn't matter. Plug y in. Let's figure out what z is. Well, let's see. This will give me, think of that as negative 5 over 1. All right, that'll give me 25 over 7 minus 2z equals 3. I'll subtract the 25 over 7. So negative 2z, 3 minus 25 over 7. I'm going to grab my calculator right here, punch that in, convert it to a fraction. I recommend you do the same as we're working along. Grab your calculator, put in 3 minus 25 over 7, turn it into a fraction, and you should get negative 4 over 7. Hey, you could do that by hand too if you wanted. All right, last thing, we need to divide by negative 2. But you know what? Because I see a fraction here, I'm not going to divide by negative 2. I'm going to multiply by negative 1/2. Because then my negatives would cancel, and my 2's would cancel, and I would just have z. What's that going to do over here? Well, negatives would cancel, and the 4 and the 2 would reduce, 2 and 1. So 2 times 1, 7 times 1. There's z. Hey, I could use a calculator there also, divide by negative 2. Z equals 2 over 7. All right, great. I've got y. I've got z. I still need to know what x is. So I'm going to plug y equals negative 7 over 5 or z equals 2 over 7 into one of the original equations. And I say or because those original equations none of them had all three variables, right? So I could pick something with y and x or something with x and z. I think I picked that very first equation, x plus z equals 0. Let's take the z, plug it in, and of course, well, if we subtract, x equals negative 2 over 7. And now we've got x, y, and z. We've got all three of them. This time, though, so I'll write the ordered triple, we call it. This time, though, because we got these fractions, we might be thinking to ourselves, is Is this really the answer? Did I make a mistake? Were they supposed to be whole numbers? We'll get a lot of questions with whole number answers for sure, but certainly fractions are going to come up, definitely. So if you get fractions, you might very well be right, but it kind of does cause us to, it doesn't quite give us the level of confidence that whole number answers give us. So in any case, really, not just because it's fractions, in any case, let's go ahead and check our answer. We're going to check that x, y, and z in all three original equations, and I'm just going to show you all three of them. Again, you might not even write this out. You might just type these in your calculator. I don't need to see it written on a test. Just do it for your own sake so you know without any doubt that you got the right answer. And always in the original equations. Don't go to the new system of equations that you created to check any of this stuff. Always in the original equations. So we had x plus z equals 0. Well, yeah, certainly 2 plus 2 over 7 plus negative 2 over 7 is 0. Well, let's look at the more difficult ones. What that was, 4y plus 3z. Is that really negative 2? Hey, put it in a calculator. And yes, it is. And then lastly, we had 2x. Is that right? Is it 2x? X is... I'm like, I'm checking myself, and now I'm... Yeah, 2x minus 5y. So that should have been a negative there. Okay. Be sure you do it right when you check yourself. 2x minus 5y. Is that really 3? I better double check. I'm checking. Yes, it is. Perfect with the negative. Excellent. They all check out. Then there's no doubt that's the solution right there. See, everybody makes little mistakes. You'll never outgrow them. Silly things are always going to happen. Okay. Awesome. Let's end this video here. I do have one more example to show you just for one type of result that can happen, and I want you to have your eyes open, or want you to have your eyes out for that and know what to do. So that'll be the next video.